Okay, finishing up chapter 2. You guys are rocking it now. Keep that up. Okay, now we are finishing up, so we're doing what's called the closure problems in chapter 2, and that's the end of the chapter. And again, what you want to always do whenever you're doing, you always want to do it, but specifically right when you're finishing a chapter, usually what's following is a chapter test to see how you learned everything. All right, that's a likely time to have a test is at the end of each chapter to see how well you got stuff. So it's really good all the time to sort of be honest with yourself. And if something doesn't make sense, you have people who chose as a career uh, to be teachers because they want to help you. So please be brave. Now, some of you sixth graders are a little bit shy. Be brave and fight your way through that shyness and ask a teacher to help explain it. Okay, that's what we like to do. And if we aren't explaining it that well, um, more people ask questions, and we look at ourselves and we want to get better, and we look at the way we teach things and maybe make some changes. So you help us when you allow us to help you. Okay? All right. The other thing about closure problems in this book, they always want you at the end to do this little graph. I usually don't make you do all these things, but I do want you to look at each group of problems. So each problem number, like this has an A and a B, but it's all about the generic rectangle, right? This has an A, B, and a C. All of these are related questions, right? So at the end of each question, and sometimes that's a group of problems, make that little bar graph and be honest with yourself. How do you feel about those type of problems? If you had a test that was full of those problems, how would you do? All right. Would you not do very well because you're totally confused, or would you totally ace it? Right? Because these are easy. All right. All right. So, and if you do say, I'm totally confused, add that three-letter word, right? Growth mindset. What is it? Yet. All right. Here we go. Here we go. Who do you want to be today? Well, I think you guys want to be Derek Carr, right? He didn't have a great game on Sunday, but he played just good enough to win, right? So, math, what period is it? Let's go fourth period. Let's have a date. November 10th. We're already in two digits in November. Oh, I think I can smell that turkey cooking now. My favorite holidays. Forces us to stop and think about what we want to be grateful for. Okay, what do we have that we're happy about? When you think of all the things you have, okay, and try to imagine living without running water. How tough would that be, right? Without electricity. Okay, so it's just some basic things, right? There's more people on Earth have cell phones than indoor plumbing. Can you go take a shower? Can you flush a toilet? Can you brush your teeth with running water? More people on Earth don't have that than have cell phones. Crazy thought. Yeah, a lot to be grateful for. On to this, though. Okay, not talking about Thanksgiving. We're talking about acing this chapter 2 test. Okay, Aruni found an incomplete multiplication puzzle, right? Um, Help him fill out the empty boxes. So what do we got here? We got 1, 2, 3, 4 going across, and 1, 2, 3, 4. So let's make some lines. Okay, and let's go ahead and make that darker and that darker so we have these numbers outside. So in the second row I had a 7 and a 35. And then if I go down 1 over 1, I got a 48 there, 45 here, up 1 over 2, I got a 42, and then I got an 8. Okay, and that 8 and 7 are outside. So how do you do this? There's something called a tangle table that you have if you picked up your packet that we're going to start working on. It's very similar to this. It's a multiplication chart, but they're not in order necessarily, right? That's not necessarily going to be a 6. That's not going to be an 8. Okay? They're not necessarily in order. But how are we doing this? This is a 7, that's a 5. 7 times what is 35? Think to yourself. Hopefully you're saying that's a 5 that goes there, right? And there's a 5 there and a 45 here. 5 times what is 45? Well, that's a 9, right? Right? Okay, and can I figure out any more here? See, 8 times 7, I could do that. Hopefully you know that's 56. 8 times 9, 72. How about this 48? Well, I could do a 6 and an 8, but here I could do a 6 and a 7. I already have a 7 here, so I'm going to put the 6 here, which will make that be the 7. And maybe I lied to you, right? Maybe they are in order. Okay, you fill out the rest of that. All you're doing is filling in the answers, right? That's a multiplication chart. You're going 5 times 6 in there. Okay. All right, easy enough. That was kind of a fun little puzzle problem, but didn't take too long. 292, all about the dot patterns, right? So figure 1 has 1 there, 1 in the corner, 1 to the right. Figure 2 has those originals, but then it has 1 more to the right and 2 more up, right? So now total dots here was 3. Total dots here was 3 plus 3 more, 6. Figure 3 is that same one we just had, right? But then it went 1 more to the right and 2 more up. So 3 more, total of 9. Now, so it looks like each new figure, I'm adding 1 more to the right and 2 more going up, right? So this was 2 high, right? And this is 4, and this is 6, right? Third figure is 6, and this was 1 plus 1, 2, right? 1 plus 2, 3, 1 plus 3, 4, right? Okay, so different ways we're looking at the pattern. We're looking at total dots. One of the things that I like to do sometimes, remember our in and out we do in our warm-up? I like doing that. Figure 1, total dots 3. Figure 2, total dots 6. Figure 3, total dots 9. Okay, you might see a pattern there. How many dots would be in the 30th? Okay, well, they want you to draw the 4th and 5th first, right? So on the 4th, I'm going to have the 2, 4, 6, and 2 more. So how many? 8. And I'm going to have 1 plus, how many? This is 1 plus 3. This is 1 plus 4. Total dots, 12. The 5th, now I'm going to go up how many? 5 times 2. 10, and then I have that 1, and then the 5th figure, I'm going to have 5 more. Okay, total number of dots, 15. Okay, so you see a pattern here. What's going to happen when X goes in, right? Hopefully you recognized what's going on here. Going up by 3. Each 1 becomes a 3. Okay, so 30th, and then X. You don't have to figure out X. That's something that I think helps you, though. It's one of the reasons we do the in and out, help you on problems like this. All right, stem and leaf plot below contains the age of the United States presidents as of 2011. So we're missing a couple, right? All right, Obama had another term, then we had Trump, and now President-elect Biden will be sworn in January. Okay, so what are the ages? How old was the oldest? Well, this is a stem and leaf plot, so that 3 means 43. That 4 means 54. This 5 means 65, right? So the youngest is 42. The oldest is 69. easy question, huh? The oldest, 69 years old, and the youngest is 42 years old. And I'm not sure, but I think that answer is going to change January 20th. I think that President-elect Biden is older than that. Okay, so 2-94, now we're looking at the histogram. Oh, we got to copy it. Represents some of the data about U.S. presidents. Filling in the missing bar. How did you decide how tall the bar should be? So that the missing bar there is from 60 to 65. And we go look at these numbers from 60 to 65. Well, I got 1, 2, 3, 4, 5, 6, 7. Now, do I include the 5? Well, let's look. 65 to 69, I got 1, 2, 3. And it looks like he went up 3. So the 65 is being included to the right. The number is included to the right. Okay? So I'm not include that 5. So I'm going to go 1, 2, 3, 4, 5, 6, 7. That's how tall I'm going to go up on that one. Okay? And so that's what we're going to do. We're going to say it goes up 7. Okay? And I'm not going to make this video too long, so I'm not going to draw that for you. You're going to have to do it yourself. Okay? Make sure you do it. Just copy this, and then this bar here is going to go up 7. How many U.S. presidents were younger than 50 years old at the time of inauguration? So that's when you go younger than 50. That's all of these here. Looks like 7 plus all these looks like 2. What's 7 plus 2? 9, right? So 294, you draw the graph, okay? 7 more in that bar is A. And for B, we're going to say 9 were younger than 50. C, last question on that problem. How many U.S. presidents were represented in this data? Well, now I can look here, or I can cheat and look here, right? But let's do it here. Let's pretend like you didn't have that data and you had to read the graph. Well, from 40 to 45, looks like there were 2 people, right? And sometimes you got to get a little piece of paper out or something, right? I don't know if you guys can see this over here, but sometimes you get a piece of paper out so you can see where does that line up, right? So the first group is 2 plus, that second group is 7, so 2 plus 7. 2 plus 7. And from 50 to 55, oh man, that's all the way up. What's that? 13 plus 13. And then down 1, 12 plus 12. That missing one was 7. And then that last one was 3. All right, so now you have to go decode my writing, right? But basically we had 2 plus 7 plus 13 plus 12 plus 7 plus 3. I'm going to group that 7 and 3 because that makes 10. And I'm going to group that 12 and 13. That makes 25. So I got 25, 10, and 9. 35 and 9. 44, which makes sense. Right? Obama was the 44th president. Trump was the 45th. That's why they call him 45, right? Okay, so we got that right. 2-95. And then once we start this, I'm going to let you in a little secret. Okay? Little secret here. 2-95. Okay, it says list all the factors of 16. Now, the way I do this, and I think the easiest way to keep track of them all, is always start with 1 times that number. And then is it's even, 2 goes into it. 6 is even because it ends in a 2, 4, 6, 8, or 0. 2 times what? 8. Does 3 go into it? Well, 1 plus 6 is 7. 3 doesn't go into 7, so 3 won't go into it. Does 4? 4 times 4. Now see how these numbers get bigger while these numbers get smaller? I just have to check in between here. And there's nothing between 4 and 4, so I'm done. All the factors are 1, 2, 4. I'm not going to list that 4 again because I already listed it. 8 and 16. That's all of the factors of 16. Okay? All right. So now it says list all the factors of 18. B. And again, let's do what I just told you. Let's start with the 1 times. Is it even? Yeah, so 2 goes into it how many times? 1 plus 8 is 9. Does 3 go into 9? Then 3 is going to go into it how many times? And the only numbers between 3 and 6 are 4 and 5. And 4 and 5, neither of those go into it, right? 4 because it was 2 times an odd number. And 5, it has to end in a 5 or 0. So all of the factors are right here. 1, 2, 3, 6, 9, and 18. That's all of the factors. Okay, that's a little different than prime factorization, right? Okay? All right. Next problem. It says place the digits 4, 7, 5, 6, and 8 in the boxes to make the largest sum possible. Okay, I think there was a problem like this earlier that I think we might have skipped. These are kind of fun to do. You play around with the numbers to see if you can get the biggest sum possible. Okay. Now, I'm going to give you a spoiler alert. Okay, I want you to try it. Okay, press pause and go try it. Then I'm going to give you a hint. You're going to try it again. Okay, go. Okay, the hint is we have these numbers 4, 5, 6, 7, and 8. And we want to get the greatest, the biggest. So I need to put the biggest value numbers in the biggest value places, right? So where's the 8 have to go? 8 has to go here. Okay, now the next two biggest are a 6 and a 7. I can put the 6 here and a 7 here, the 7 here, 6 there, right? So I can have 8 70 something plus 60 something, or I can have 8 60 something plus 70 something. Doesn't matter. The shortest, the smallest, the 4 and the 5 should go here, and I can have a 4 and a 5 there, or I can have the 5 and the 4 there. Right? And again, same thing here. I can have a 4 and a 5, or I can have 865 plus 74. And guess what's going to happen when I add all of these? All of these are going to equal the same thing. That is the greatest possible, right? And again, you put the biggest number with the biggest value if you want to get a high number. Okay? Okay, what is the secret I was going to tell you? Check out this. Flip a page. Oh, you got all the answers. You got all the answers. Look at that. Look at that. 1, 2, 4, 8, 16. 1, 2, 3, 6, 9, 8. Oh, man, all the answers. I didn't have to do that work. Yeah, you had to do that work, right? All right, making a Venn diagram for 297. Okay, there's 50 students. Okay, 15 are taking English, 30 are taking chemistry. Of those students taking English and chemistry, 6 are in both. So, Venn diagram, they have at least 2 circles, and they overlap. We'll call this English and this chemistry, an E and a C. Makes sense, right? So you use variables sometimes, but make them make sense. Now there's a total of 15 taking English. I'm going to put a 15 there. Okay, and 30 taking chemistry. But it says 6 are taking both. So I need a 6 in here. But if I put a 6 in there, all of a sudden I have 6 plus 15, 21 people taking English. So when I put a 6 in there, I need to take 6 away from there. How much would that give me? 9 go there. And same thing here. Once I put a 6 in here, I got 36 people taking chemistry. I got to take that 6 away. So I have 24 plus 6 more. That's a total of 30. Okay. Now, I don't like erasing. I like to show. This shows where I got all that. So, but it said there's 50 students. Where's everybody else? Well, they must be out here not taking English or chemistry, right? Okay, so it says how many are taking chemistry and not English? That's 24. And our math was 30 minus 6. B, how many are taking English and not chemistry? So that was 15, but I subtracted the 6 and got 9. And C, how many are taking neither? Well, that's a total of, right? I have 15 and 24. That's a total of 39. It said there was 50 people here. So 50 minus 39 equals 11. All right, 2-98. Cruising through this. This is a closure. This usually takes a lot of time. So this is a little bit harder than a normal homework, right? A little bit harder. We're learning everything. All right. So there's a rectangle. And this is a little trickier than you think. Okay? This is 2 yards tall and 3 yards wide. And they say, what is the area in square yards? That part's easy. The area in square yards is 2 yards times 3 yards equals 6 square yards. Okay, but now it says, how about in square feet? This is where it gets tricky, right? Here's your 2 yards times 3 yards. How many feet is that? Well, each yard is 3 feet. Right? So now I did have, how many feet wide is this? 9 feet. How many feet tall is that? 6 feet. Okay, so 9 times 6 is 54 square feet. How can that be? I thought there was only 3 feet in a yard. It even says that. 1 yard equals 3 feet. But let's think, 1 square yard. 1 square yard is 3 feet tall, 3 feet wide. How many square feet is that? That's 9. So each square yard is going to be 9 square feet. And what's 6 times 9? Boom. Okay. Now, what's the perimeter of the rectangle in yards and in feet? Perimeter, 3 plus 2 plus 3 plus 2, 5 plus 5, 10 yards. That's not square yards. Remember, perimeter is just a length. But how about the in feet? 9 plus 6 plus 9 plus 6, 15 doubled. Perimeter equals 30 feet. Got it? All right, last one. I am going to write on the back of this paper. We have 2 generic rectangles, area models. Remember how you used to call that area model last year in 5th grade? 40, 30, plus 5, plus 4. Don't forget from the plus signs. Okay, so we're going to write it all, then write the numerical sentence. Okay, so 30 times 40 is 3 times 4, 12. Move the decimal over 2 spots. 30 times 5 is 150. 4 times 40, 160. 4 times 5, 20. Want to add those up. 1200, 150, 160, and 20. 13, 1,530. Okay, but now it says write the numerical sentence. Okay, so numerical sentence, you can write 34 times 45 equals 1,530. If I wasn't in a hurry, trying to make this long recording not as long, right, I would prove that. You should probably prove that. Great thing to do. Check your work. Okay, I got a 40 here. I don't know what goes here, but there's a 300 there. I know what 800 is there. And some people are saying, wait a minute, this looks familiar. Yes, if you did yesterday's warm-up, the answers are done for you. So I'm not going to do it again. Go look at yesterday's warm-up. Okay, my class, I even made an Ed puzzle out of it, right? All right, go check it out. And remember, all the answers are right here for you to check. Don't just give yourself the answers. Figure it out. And if you don't figure it out, those are ones you got to ask questions about, right? All right, good job, everybody.